want those 2 hours full and then the other one?
Hey, can you? Hey, Tracy, is it acceptable to shut those ones off because then I don't get a glare?
It's nice and bright out today. We're good.
I know.
Okay, last but not least is the future, not of this program, but of things, hopefully. So Nicole Watson is joining us. She is we're going to call her Ph.D. candidate at awesome Grayling.
Thank you. So it doesn't really show up too good, but there is a MSU Department of Fisheries and Wildlife logo on that side. Sorry. So first of all, a quick survey, because right before I came up here, I merged 2 presentations together because I thought you guys looked like a fun group. And I have a really fun presentation that I merged into this one. So doing here like Star Wars. Yeah. It's always like, I always am really risking it when I do presentations. And I'm like, who likes Star Wars? And if somebody like goes, live long and prosper. And I'm like, oh, you're going to hate me now. Sorry. So, if you like Star Wars, you already noticed a thing. I'm calling this New Reinstruction A New Hope, episode 4. So you'll see some Star Wars themes embedded throughout this. And I'll give you a quick introduction here on some abbreviations we're going to use. So AGR is going to be Arctic Grayling, BKT, brook trout, ENT, brown trout. All of you lovely DNR folks already know all those. But everyone else, if you have a question, let me know. Any time we're going through, regardless of what it is, feel free to stop me. At the top here are some Arctic Grayling babies, and look at that nice dorsal fin already. This is a brook trout. Sorry, we were talking fishing earlier. And this is one of the brown trout. It's an age 1 that I collected from Sanborn Creek. It was pretty fun. I had 15 brown trout in this tank. They're all about this big. I put them from the stream into my cooler, and I put a net in to transfer them into the tanks at the lab. And as soon as I put the net in, they wanted cover so bad, all 15 fish swam into the net. It's the easiest fish transfer I've ever done. So, starting out, might look familiar for you Star Wars people. So a long time ago, Michigan River is not that far away. I'm going to give you an introduction to Grayling history. With that being said, I'm working on the transition out of that slide though into the presentation. I haven't quite figured that out yet. This is what adult grayling looks like for those of you who have not seen them. These are 2 adults from the Chino River in Fairbanks, Alaska. It's actually where the eggs were collected from. So this would be what we would expect to see eventually in our Michigan streams. We could have potentially different color morphotypes. You can see the one on the left is really nice and blue. The one on the right has a really unique silver color to it. The majority of them do tend to be more silver, but all patterns of color on the dorsal fin is unique. So historic range in North America here. So the purple is really the historic range and it's also current. And then we have our past introduced, our past in Michigan here, and in the Keweenaw Peninsula. Now what's unique about the Keweenaw Peninsula, and I have it highlighted here, this Otter River, we think of as actually transported there. So we don't think they were native to the otter in the UP. So what we're starting to believe is that grayling were pretty much knuckles north in our streams. So what happened? It was a multiple of factors, and they were compiled one on top of the other. So overfishing, logging, and competition. So here is the painting of this discussion, if you guys earlier, right here. This is the old historic painting of what a true Michigan grayling looked like. It was a common scene that you would notice on the Salmon River system historically, and another depiction of the Michigan. So when I talk about overfishing, give you guys an idea on what I'm talking about, because to most of us, we think of overfishing and we're like, wow, you go out and you catch 10 fish every day. So Chauncey Lively recalled in an interview that Paul Young explained to him that people would go out and they would catch so many grayling, they would just toss the fish up on the banks behind them, and they would be shoulder height, this pile of dead fish. And then when they were done fishing for that day, they would go over to the shoulder height pile of fish, pick out a couple that they wanted to take home, and leave the rest rot on the bank and the animals would eat them. That's the extent of overfishing I'm talking about. I'm not talking about going out and exceeding your limit every day of 10 fish. So people would catch hundreds of pounds of fish. They would put them into boxcars and they would ship them to Chicago, New York, and Detroit to restaurants. So these fish were absolutely decimated. What you can imagine is, if you think about it, maybe if we only had overfishing and not logging and not competition, maybe they could have came back, and people started to think, wow, what are we doing to our fish? But then you have a species that was stressed to this extreme, then you log. You had extra sedimentation into the streams. So this is the logging we're talking about too, for those of you who haven't seen historic logging in Michigan. We're talking clear cut, we're talking running logs into the banks. So we have scouring, we have sedimentation, we have dams, we have release of these logs, loss of grayling eggs. So that on top of overfishing definitely had an impact on this fish. So then, when you're a trout fisherman, you no longer have a high density of grayling. So what are you going to fish for? There's no fish. Well, let's throw in some other fish. So brook trout were brought down from the UP. Brook trout were also native to some streams. So in the Jordan River, it's been documented historically that brook trout and grayling did coexist. Brown trout, who knows the origin of brown trout? Germany, thank you. Rainbow trout, how about where rainbow trout are native to?
Pacific Northwest.
Pacific Northwest. So that provided competition for resources. This right here is a nice fish that I collected electrofishing during my master's degree. This is a nice lunker on a mousing trip and a cute little brown trout, or brook trout. So previous restoration attempts, they failed. There's 3 core reintroduction events. I've condensed a few of them into episode 1, conveniently for showers. So in the range of 1900 to 1941, they tried to reintroduce fry. Then we got to the second one, 1958 to 1960, again they tried to reintroduce fry. Then the most recent was 1987 to 1991, and they stopped, instead of fry, because fry didn't work, we stopped yearlings. Every single one failed. One of the main problems is they would put these fish in and they would disappear. So you would stop them to a particular site, you would go back to see how they're doing, and they're gone. There's no sign of them. So after 3 episodes of failure, what makes you want to try again? Well, research, not stocking fry, and having a collaborative effort. So what really brought this up is in Montana, their grayling stocks were being decimated also. They were really falling down. And they were having the same issue. They would try and restock, and they would try catch reared grayling, bring them in, stock them into streams, and they would outmigrate, they'd disappear. So same thing, right? Sounds exactly what we had in Michigan. So they started using this thing called an RSI, the remote site incubator, and I'll get to it in a little bit too. You put the eggs in the remote site incubator right on the stream you want to introduce the fish to. So they imprint on that water immediately at whatever stage you put them in. And what Montana found is, lo and behold, you put these fish in the remote site incubator, they imprint, and they develop homing into that site. So they have stream fidelity then, and they'll hang out there, they'll hatch, they'll hang out at that introduction site and come back to it to spawn. So that's exactly what we want, right? A fish that comes back. So their success has led to us trying this again. So those past Michigan problems led to that RSI use. And here's an example of an RSI system. So it's in essence 5-gallon buckets. The water comes in through the bottom. There's gravel here, an egg mat, and then outflows here. and they're using it really a rain trough, and they'll go right back into the stream. So you can see the inflow of the water is from upstream here. You can see it better in this one. And they'll flow down. So getting into the egg collection for my research, Alaska Fish and Game collected them from the Chena River, like I had said, outside of Fairbanks. It's a wild stock of grayling. They collected them on May 15th. Now, those of you who have already reared for salmon in the classroom, this is what I find really unique about grayling. So eggs are collected on May 15th. It was a collection from 22 pairs of males and females, and I collected a total of 5,000 eggs. I guess I'll get to the most interesting part in a minute. Remember that May 15th date. Since I merged these two, I'm kind of thrown off here, I'm sorry. So here's some pictures for you of the Alaska area. So this is inside their hatchery. I would love to have this aquarium in my house. There were grayling in there, there were steelhead, there were some char, it was beautiful. This is the inside of their hatchery here, and this is the Chena River, to give you another view. So now remember, May 15th, those eggs were collected, right? So I arrived in Fairbanks on May 30th. The eggs were already at egg stage on June 4th. Is when I departed with eggs. The hatch date, this was really interesting. June 8th was the hatch date. They were collected May 15th. They hatched June 8th. And in Alaska, they specifically held them at a colder water temperature than they normally would to delay development to allow them to go up there, grab the eggs, and go home. So to transport the eggs, I'm sure you guys have been familiar with egg transport. So it's cheesecloth soaked in water inside a styrofoam box. Let me tell you, carrying this box around in an airport is fun, especially when it's empty. Because our trip up there, I was so worried that what if the box got lost, how am I going to bring it home? That it was my carry-on. So my husband came with me, and we would pass the box off to each other and go, "Hold it!" and we'd shake it all around, and people don't want to sit next to you. So to give you the whole path here, we started in Fairbanks, Alaska with the eggs. Our first layover was in Minnesota, so I got the eggs out. The airline staff was great. They kind of looked at me like I was nuts at first. When I said, "Do you have somewhere that I can put this box flat? It's viable trout eggs. I need to make sure that they get home." And they like put them in a closet for me and everything, because they just had to stay flat. When we would stop, I would open the box, fan the eggs a little, allow for a good oxygen exchange, and then we moved back home to Detroit, where we brought them back. And this is the eggs in their first moments in our incubation tray. Really kind of looking So I wanted to provide you with some information and life stage pictures here. So these are the 5,000 eggs in Alaska. This is traveling home. And this video, that's their yolk sac. So I had removed eggs that had fungus on them, and the healthy eggs that were next to them, I put into this tray. Went back to wash off some of my equipment because I was going to save these for analysis for thyroid hormone. I came back, all the eggs hatched. And so now, this is immediately post-hatch. Look how much they're swimming around, and look how tiny that yolk sac is. And compare that to your salmon that you have in the classroom. It's incredible. So that small dinky yolk sac is part of the reason that these guys are swimming this much immediately post-hatch. I was amazed. And I have never reared fish from eggs before. This was my first time. So this like completely threw me off. So some more information here on rearing and some pictures so you can see development. So when they hatched out, they were about 11 millimeters. Everyone described them to me as they basically look like a thread with googly eyes. Yeah, they do. So this is immediately post-hatch. Here's a couple days old. Here is development of that dorsal fin. You can see it right there. And then this is when the poor guys started their predation trials. So they were about 23 millimeters at that point. So that was actually only 2 weeks old. They were already about 22 millimeters. Here's a video, and I hope you can see some movement here. I don't know how well you can see it. If you want to look at it on my computer, you can see it on this computer. If anyone wanted to get a better view of this, either come see it later or look at it on my computer. That's perfectly fine. Let me get this going again. So on the left, the fish are in the pond for 2 days post-hatch. That's how much they're swimming in the water column. This here is kind of hard to see. Yeah, that was just a big blob, I'm sorry. There's a vortex of fish swimming right here. This is 24 hours after ponding, so they are 2 days old. I started feeding them immediately. It's an Artemia solution, and they cue in on that food so quickly. The next day I came back, I looked into my holding area, and they were vortexing around the feeding drip. So it actually resulted in a starvation event, which this coming year I'm going to avoid by flushing in even more food. So here's some more rearing pictures here. So further development, this was the day I started my predation trial to give an idea of size here. I consistently made sure that I tried to get photographs of them when they were in the same container to see differences in size. And yes, they eat each other, yes. So the predation trial, I'll get to that, it's with age 1 broken brown trout. Sorry, I didn't preface with that. It sounds brutal that it's a predation trial, but there's a reason. I'll get into it in a bit. So they do eat each other also though, which we found out when we started looking in our holding area, and this huge fish stood out. So I have blue lines next to the average size fish and a red line next to the cannibal. Initially, we only had 4. They started to appear like sequentially. So initially we had Dahmer, and then we started to name them subsequent cannibals until we ran out of names. What was that? There was a Hannibal, yes. Hannibal, I think, was number 2. You have to make light of it when you're wondering how some of your fish are disappearing. But when you have 5,000 fish, it's hard to keep track of your numbers unless you're pulling out dead bodies. And then we realized we had cannibals. And Alaska Fish and Game was like, so how many fish do you have left? I don't know. 5,000, 4,000, 53,000. I don't know. So here's further development here. So you can see now they're about 53 meters or 53 millimeters at this point. And this is during the competition trial, one of the ones with the brown trout. You can see it had some fin degradation. We'll get into the competition trial in a bit too. Some more development here. So they started to form that square-shaped mouth in really good jaw formations. You can start to see here that nice jaw formation. The percular plate here is nice and formed. Some other unique characteristics to Grayling is this one was starting to lose its bar marks, and it started developing these dark V shapes. They get, as adults, these dark V spots, and they're unique between fish. So no two fish are alike as far as their spotting pattern. And look at that fin formation. And this is absolute beautiful baby fish here.
What's the time scale in that size?
This one, I think, was about 3 months old. So now I'll get into the research aspect of it a little bit. So this is a color of the dorsal fin of a grayling. So this would be a male. That spotting pattern that you see is unique between every single fish. Again, no two fish will be the same. I wanted to give you an idea of the overall lab setup. Tracy can tell you it's incredibly loud in that lab because we have 2 chillers. These are single horsepower chillers on the top. We keep our water at about 54 degrees Fahrenheit. We also have the head tank, which feeds everything. So this is an 800+ gallon recirculating system. I have a UV sterilizer. It's the most critical part of the entire system. Keeps everything good and clean. I have an elevated camera system. 3 artificial streams. The net surrounds are to prevent the larger fish from jumping out of the artificial raceways. We need to be able to record everything via camera system. So I couldn't put a cover over the streams. These net surrounds actually work phenomenal. They were a pain to put up, but they are godsend. And then I have a sand filter. It's a 300-pound in-ground pool sand filter. Holding tanks here. There's 2 individual grayling tanks if you look through that mesh there. And this was the broken brown holding tank. I have exchanged these 2 smaller tanks for another large tank for next year. And then I have a collection tank. So now we'll go over water flow and it'll all make sense a little bit more. Keep in mind, this area is 8 foot wide by 17 foot long. So it's a lot of stuff in an extremely small space. So water flow, if you follow the arrows, it goes out of the head tank, It distributes down to the artificial streams and all of the holding tanks. I have a semi-laminar flow across every artificial stream. It gravity drains down through the outflow. It goes from this outflow back to the wall, around and down into this collection tank, which is on the ground. Gets pumped in through the sand filter, through the UV sterilizer, back into the head tank, gets chilled, and recycled all over again. We do water changes, about 100 gallon water change every 2 to 3 days, depending on our fish density. So now we'll get more into the science aspect of it and the research. So the overall goal is to gain insight into potential grayling impediments to successful reintroduction of this Arctic grayling to our Michigan streams. Our main 2 objectives are to assess potential effects of predation and competition between Arctic grayling and our resident trout, namely brook and brown trout, and to evaluate whether early life imprinting corresponding to the RSI use is key to enabling stocked grayling to establish residency in the streams. So it's a 3-part study. It's imprinting, predation, and competition are the 3 core aspects, but I am constantly adding on additional side projects as well. So we'll start with imprinting. So background here, capturing rear grayling, like I already discussed, in both Montana and Michigan, quickly outmigrated and disappeared shortly after stopping to the streams. Montana found using those remote site incubators resulted in the grayling establishing its residency at or near the incubation site. And so this really suggests that there's potential for imprinting to the stream at really early life stages. Recent work with Pacific salmon indicated early life imprinting is key to spawning migrations. But there was no information on imprinting processes of grayling. That's where we came in. Our study is seeking to address this knowledge gap for grayling using methods that are employed on other fish. So thyroid hormone analysis will be used to determine life stages at which imprinting is likely occurring. There's a study that found elevations in plasma thyroid hormone level in juvenile coho are associated with timing of imprinting. So what we basically do is we go and we collect different life stages of fish. So I collected pre-hatch, eyed egg, immediately post-hatch because my eggs that I planned on analyzing hatched. So then I also added on swim up, and then I had 8 total biweekly samplings of fish. So what I plan to do is I'll go through and I'll extract the plasma, extract tissue, analyze it for plasma thyroid hormone levels. If it shows an elevation in thyroid levels, then we are thinking that that could indicate the fish is imprinting at that life stage. We're also doing water trace experiments to determine if the grayling develop a preference for their home water. This currently, the studies are completed, but we're analyzing the data right now on those. But we did notice what could be a positive association to their tank water. However, it's hard to say if it's an avoidance of the water blank that we chose, or if it's a true preference to the tank water. We're still going to figure that out. We have to toy around with it for next year. So if we go on to predation. So predation by resident trout, you can all guess, may be one of the most significant hurdles to establishing our grayling populations, right? There's a lot of fish out there. We are not planning on rope noting streams and replacing them with grayling. So we're just going to fit them in where they can coexist with the current fish community. So a study in Montana found a negative association between density of brown trout percentages and larger and Arctic grayling. So what we mean by negative association is the presence of those larger brown trout decrease the growth of grayling, or they simply eat the grayling. And like with imprinting, there are no studies on vulnerability of grayling to smaller trout. So I'm focusing on the effects of smaller size classes of resident brook trout and brown trout on newly hatched grayling survival. So to give you some size ideas here, these are age 1 brook trout. They're about this big. Here's the grayling about ready to go into the predation trials, and this is the brown trout. So smaller trout are often found in higher densities in streams. So think about it, you have more fish that hatch out, more that survive. You have a high density of age 0s, you have a high density less than age 0s of age 1s, 2s, and these subsequently will dwindle down, right? And think about it as a size ratio, okay? If you have a child and you give them a quarter pounder with cheese, they're going to get fuller quicker on that quarter pounder with cheese than, say, I don't know, a football player, right? So think of that with fish too. So eggs and fry are nutrient-rich diet items for smaller trout. So these age ones, they can eat a couple fry and they're like, wow, that's good nutrient-packed meal. Where a larger fish, they may just try and go after something else. So I have 3 artificial streams. If you're looking at them from the top down, this is what they look like. I have my inflow here, my outflow here. And if this channel wasn't full of water right now, and it was just the main section of the channel, the deepest part, the thawing was wetted, you would see a pattern that goes like this through the string. I have a point bar here. So this is only maybe an inch deep of water here. The water wraps around here, it's faster flow here. And another point bar, so it comes around and then opens up into a pool. My raceways are only 10 inches deep, so it's a pool. I have vegetation in this stream. I have undercut banks. I have woody debris. I have slate for the fish to hide in. I have a large cobble up here. I have smaller gravel here, and then this is a small pea gravel. So I've captured from the stream age 1 brook and brown trout. And for the initial predation trials, so this hasn't been done before. So we were kind of like, where do we start? There's so many different parameters we can try. There's so many different things we can do. So for the initial year, which was just 2018, I'm in my first year still, we did multiple treatments with an adaptive design. Trials were recorded remotely using a camera system. And the brook trout acclimated really well to the containment environment. I started with 15. I had 1 jump out of the net. I still have no idea how it did. It ended up with 14. The brown trout started with 15, ended up with 3. They stressed. They were really bad. The cruise pets guys aren't here anymore, but I was going to give them a huge shout out because there were so many times that I ran up to them and I'm like, what is going on? I can't get my fish to eat. They're stressed. What am I doing? We tried everything. We ended up with 3 brown trout. They just really stressed. I had to have them each isolated in their own area in order to get them to calm down a bit more and use in the trials.
What strain did you use?
So I collected them from Sanborn Creek.
From Sanborn, okay.
Yeah. So I'm debating Sanborn Creek has a really high density of brown trout. But since they stress so much as age 1s, I'm debating going back to Sanborn for next year or to just try somewhere else. I want all wild fish, so they're exhibiting more natural behavior in the streams. Even though my Grayling are capturing fish, but there's documentation that shows Grayling adapt very quickly to different environments, which we saw. So acclimate the predator to the stream for anywhere from 8 to 12 hours. We regularly fed them because you don't want to skew your results in a predation trial by putting in a starved predator, right? So we fed them blackworms out of a cone feeder. We also fed them bloodworms as well. We would add 20 grayling to the stream. So we had a beaker on fishing line. You would have the 20 grayling in the beaker. You would randomly choose your location, pull the beaker, and walk away, and the trial would go anywhere from 1 to 2 hours. At the end of the trial, we would scoop out the predator, and then we would recollect all of the grayling. Now, remember how small the grayling are, and I have that artificial stream. We also did a control. You can see here, we did a total of 10 controls at various trial lengths. And the reason we only did 10 is because there was only one time where we caught only 19 grayling in the control raceway. But 2 hours later, we found them. So we always caught all the fish in our control. So we knew that we were really good at recapturing these fish. So here's just an idea of the parameters we changed. The light, either day or night, the length of time, 1 or 2 hours, and then the total number of predators per raceway. So I have 1, 2, or 3 predators per raceway, and you can see pretty obviously that we settled on 1 predator per raceway. Based on the size of our artificial stream, even 1 predator is higher than what they would naturally see in our streams in Michigan. Our raceways are 10 foot long by 2 foot wide by 10 inches deep. So it's a lot of numbers, but I'll draw your attention to this. So 19 was the maximum number of grayling preyed upon by any fish. And it just happened to be brown trout in a predator trial. To compare that to brook trout, the maximum number of grayling prey with 2 brook trout was 12. With 3 predators, it was 17. So even with 3 brook trout, they did not exceed the amount of grayling preyed upon as the brown trout. These were all within the same, I think they were about a day apart. So the grayling would have been roughly the same size. Brook trout predation was relatively additive, so each time we would add a predator, it would about double or triple. So overall, grayling vulnerability appeared to decrease over time as the development progressed, which you can imagine, right? The fish's fins develop greater, they're able to see better, they're able to swim rapidly to avoid that predation. And it's consistent with the opinion of the biologist in Montana, who thought that isolating them in a particular area of the stream before giving full release would protect them from predation. The grayling started to exhibit schooling behavior, hiding in the substrate, and rapid movements to avoid predation. So they would school once they were about 2.5 to 3 weeks old, and they would also start hiding in the substrate, which was very beneficial for them, but a pain in the butt for us trying to recapture them. We would look for tiny caudal fins sticking out from the interstitial spaces. We started to started checking the raceways every 2 hours to make sure we found every fish. You would think you had them all, and you would be walking out the lab and see an additional grayling in the raceway after scooping out. So this does have a management implication for once we're ready to put the fish in. So understanding catch and early life survival rates will help us better estimate the number of eggs that we want to start with in the RSIs, given the stream reach with the total fish community and how many are going to be preyed upon for a given period of time. So if you want X number of graylings to survive predation by, say, 4 months, this is the number of eggs you want to start with. So for next year, I'm planning on having several repeated trials in a shorter period of time, starting sooner after hatching. And I'm also going to fine tune those parameters. So I've settled on doing day and night trials, 2-hour trial periods with only 1 predator at a time. And I'm also thinking about putting screens over some of my lights to also mimic dawn and dusk. Questions so far? Yes. Cruise has LED lights. They're full spectrum light. And it was, I walked into Cruise and said, I need a daylight light. What do you suggest? And they've been great. But the only downside is they turn on and off. Right. Those would have, I think those would be really beneficial. I would love to use those because it would mimic a natural system, but they're a lot more expensive. Okay.
The RSIs in Montana, what size were they, or how old were the fish?
They initially were considering containing them for, I believe it was a shorter period of time, like a month maybe. I'm not exactly sure. But I think now what they're doing is they swim up, they go out the outflow. Yeah.
Backing up, because I'm still learning how to use it.
Oh, that's fine.
So brown trout, you said, and which other one were those introduced?
Yeah, rainbow trout and brown trout were introduced. Brook trout, they were native to the periphery of Michigan, so you have your coastal brook trout that would develop residency in streams. They were primarily in the Upper Peninsula. Brown trout came over in the late 1800s, and so did rainbow trout from the Pacific Coastal region. There's a really good book, if any of you are interested in learning more about rainbow trout. It's called An Entirely Synthetic Fish, and it's the basis of how rainbow trout are pretty much taken over the world. So they have been introduced to every continent with the exception of Antarctica.
So before all the overfishing, the rainbow and the brown.
The brown trout and the rainbow trout were not here. Overfishing started in about the mid-1800s and went on from there. So historically, streams that had grayling were primarily dominated by grayling and non-game fish. The Jordan did have both brook trout and grayling. Yeah, I mean, they were already overfished. So then adding those, I think, really just kind of pressure on them.
Are there wild
Not in Michigan, not in Michigan, but there is in Montana. But they've had to work so hard at re-boosting their stock, that their genetics are a little off, which is why we're not getting eggs from Montana. Alaska's a lot. Anyone else before we go on to competition? Okay. So the competition between age 0 resident trout could adversely affect grayling survival. So think that you have too many fish in one area, they're all going to fight for a common resource, right? And that resource is limited. So this can be due to the distinct size advantage early in growing season, and aggressive interactions can push grayling into poor microhabitats. So I'm focusing on changes in growth, behavioral interactions, and habitat use of age 0 resident trout with grayling in the same artificial streams that I use for the predation trials. So again, 3 artificial streams, wild captured brook and brown trout, age 0. I go out and collect them. They are no larger than this. The reason I'm going to do that is I draw a ruler on my finger when I field sample, and that is 90 millimeter mark right there. So anything less than 90 millimeters when you get to like August is indicative of an age 0. It's rare that they would be an age 1 brook or brown trout at that point. The treatments, I had 3 for 3 streams. Control, which is 20 grayling. Brook trout treatment is 10 brook trout, 10 grayling. Brown trout, 10 brown trout, 10 grayling. That way I kept all of the density of fish the same. It was a 2-month trial, bi-weekly weighing of the fish. And it's important to know what their weights were initially going in. So at week 0, all of the grayling were approximately 1 gram in total weight. The brown trout and brook trout were approximately 2 grams in total weight. So they're about twice the size. I did automatic feeding, so I mimicked surficial and drift, because we all know fish eat in different areas of the water column and have different preferences. So my surficial was freeze-dried lugworms and mysis from an automatic feeder at the head of the tank. Then it would be drawn down with the laminar flow. My drift feeding was a fresh time market fruit-infused water bottle. It was perfect size. I drilled a hole in the sides, put an outflow pipe on, and I had an air stone in there and a dosing pump. The dosing pump would add a certain volume of water, cause the water in the bottle to overflow. The worms and mysis that were thawed out would then go down the pipe into the water. These were frozen, thawed, so they would sink in the water. And a submersible water pump in the side of the tank, so all of this is about the mid-channel region. The items would come in, they'd hit the water, they would hit the flow from the submersible pump, and it would be mimicking a drift feeding system that you would typically experience in a crossroad. Trials, again, recorded remotely with camera system and limited human presence. We were only there simply to clean and care for the fish, that's it. So the overall data here for the 8-week trial, the green is the control, so only grayling. The orange dash is the brook trout treatment, and the purple is grayling with brown trout. So, a couple of things that were pretty interesting is this second week, it was pretty much what I expected. The bars here are standard deviation bars. So standard deviation of the mean tells you the overall distance that they were. I was kind of surprised on week 4 when brook trout treatment was creeping on the grayling treatment, and I was really surprised at week 6 when the mean growth was better with my brook trout. And when you look at the standard deviation bars, it's pretty tight. One thing I want to also draw your attention to is look at the wide spread of the standard deviation bars for my control. I have some fish that really didn't grow that much, and I have others that grew pretty well. So based on this is again preliminary data, so it's only one trial, so keep that in mind. Presence of brown trout really limits the growth of grayling. Presence of brook trout, no, they do just fine. The other concern is, well, what about the growth of the brook and brown trout, right? Because those are also in our streams. People fish for them. We want to make sure that we're not going to suppress their growth. Brown trout, the average weight of brown trout was ahead of where they started. However, at the end of the 8 weeks, I had one single brown trout that grew to 10.87 grams. It started at 2 grams. It ingested at least 2 of my grayling, I think. The rest of the grayling, so I had 60% mortality in the presence of brown trout. 4 of them we found. 2 we did not. So we're thinking that the dominant brown trout ate them. There were 2 other brown trout that exceeded 4 grams at the end of the 8-week trial. The rest were all lower than 4 grams, and one of them was only slightly above 2 grams. So that was telling us that both intra-species competition was really high amongst the brown trout as well, not just having an influence on the grayling. The brook trout grew just fine. They had absolutely no problem. So the growth of the grayling may not be affected by the presence of brook trout, but in the presence of brown trout, they're really suppressed with that 60% mortality as well. Again, single trial. We'll know more in a couple years. So the grayling received a double whammy, and I've been told that these are whammies from some game show. So in the presence of brown trout, the grayling do get a double whammy. They have a high predation rate that potentially continues across a broader period of time, and then the influence of competition is really high. So significantly reduced growth and body condition in the presence of resident trout, especially brown trout, will lead to poor survival, especially over winter during the first year of these grayling. Brook trout are a totally different story. So before I start this video, I just want to draw your attention. So, and a quick, I don't know if I mentioned it, when I allowed the fish, the brook trout and brown trout to acclimate to the artificial stream, I collected them, I put them in the artificial streams immediately before the competition trial and left them alone for a week. I would feed them regularly, both the superficial and the drip pump. And the brook trout and brown trout would scatter every time you would come by. They would hide in this woody debris, they would hide under the slate. They just were so stressed. I added the grayling at the start of the competition trial, and within 5 minutes, the brook trout came out of hiding and were swimming with the grayling. The brown trout did not do the same thing. One of them started to come out and then went back to hiding. So in this image, there's a brook trout here, the brook underneath these 2 fish. This is a brook trout, this is a grayling. Brook trout, grayling, grayling, brook, grayling, grayling, brook, brook. And there's a brook trout up here somewhere, and there's a grayling that will zoom in and out. But just watch the interactions that they have. So the competition influence is high between grayling and brown trout, but it's really not suppressed in that brook trout population. And during our lab checks, if anyone can hear the cantina music, that's kind of what it was like in the raceway. You would walk by and this is what you would see. I mean, you would stand at the end of the tanks, you could look at the grayling control, and the grayling are schooled in the center area of the tank. And they're swimming and behaving like this. And then you look over at the brook trout tank, and this is the brook trout treatment. You would have to really focus and look for the spotting pattern of the tar marks on the backs of the brook trout and also the coloration of their fins to distinguish who is who. The other thing we noticed is the brook trout hung out more by the woody debris and lower in the water column, where the grayling would hang out by the woody debris but higher in the water column. So that was the main difference, and they chose their microhabitat accordingly. The brown trout raceway, you would walk past it and you would have to focus before you saw a fish. There was no schooling, fish were pushed to the perimeter, grayling would hide on top of this artificial vegetation that's suspended up in the water column to be like an overhanging bank. And there was a grayling that would force himself on top of it to hide from the grayling. But this is that water pump I was telling you about, and this is the outflow of the food. So by the fish hiding here, the food would come out, the dart grab a bloodworm and come right back. That's the only way that fish survived. So really, there is still hope. These initial trials provide critical insights to demonstrate the feasibility of the introduction. Because I even had doubts at first when I've always dreamt of studying grayling in Michigan and trying to bring them back. But you fail and you fail again and you fail again. And it's like, are we insane? We're trying to do this again. But this is showing me that it is possible. So it's going to help guide in targeting suitable fish communities where these fish will thrive. So really based on if these results are consistent over the next couple of years, we would just focus on streams that are primarily dominated by brook trout. Avoid a brown trout stream. Doesn't matter how bad you want to put grayling back into the South Branch of the Salmon River, they're not going to survive. Just don't do it. So over the course of the next couple of years, we'll get that full story. And then we'll be able to tell if they can fit into a certain fish community. So, when and where? Those are the big questions, right? We're still a few years off to seeing eggs in the river. Open Fish Hatchery will be rearing the eggs, and they need a UV sterilizer, and they're trying to get funding for this. So this whole reintroduction project is funded through private donors. My entire Ph.D. is funded through the Bender Foundation. It does not take any Michigan DNR money. Open Fish Hatchery for the UV sterilizer is not using any DNR money, because that's the other question we get from fly fishermen. Are you using Habitat Initiative monies to put these fish back in? No, we're not. So it's kind of holding things back. So once Odin has that UV sterilizer, we can start getting the cohort for the brood stock. We need 2 years of brood stock, and they take 3 to 4 years to mature. So this year, I'm bringing home extra eggs, so I can start the first brood stock cohort with my leftover fish. Then Odin should have their sterilizer in enough time where I can transfer the fish to them. Next year, they'll have another round of brood stock fish. Those 3 to 4 years will go by. So approximately 5 to 6 years, we'll have eggs in RSIs on our rivers. There's nominated rivers already. The Maple, Upper Jordan, Newman, and Upper Manistee. Just because we say that they're nominated does not mean they're necessarily going to get fish. And they're also not necessarily the main sections of those rivers. It could be tributaries that feed into it. So you might want to focus on a small headwater tributary where there's brook trout but no ground. Nominations are continued to be reviewed. So that's the other thing to consider. If you're looking at this going, I know the stream that can hold these fish and I want to get them in there, get community support, email the DNR. There's information on the migrayling.org website. Submit it. The big thing is if you want the system accepted, you have to have community support. I personally nominated 5 streams, but there's not community support for them yet because it was just me. So you can help. Keep that in mind. If you go to rewildmichigan.org, they are one of the primary outreach and fundraising committees for this overall project. So if you go there, you can make a donation. You can find out more information for the Grayling project, and we can all help bring these fish back. And so think of it as you could potentially go out in maybe 10, 15 years, and you could be on a water system in Michigan, and you could fish and collect a brown trout, a brook trout, a rainbow trout, and a grayling, all in the same day, all within a drivable region, potentially all in the same system too. So thanks to my funding provider, the Winder Foundation, and my undergrads, my advisor, everyone else. Thank you to you guys for inviting me to this. This has been awesome. I have to tell you, I'm a certified secondary science teacher, and I taught 6 months. I give you guys credit because I had to show myself, so I did not go into teaching after that. So thank you. You guys are amazing. Yes.
So with your trials, where you're testing like competition and predation.
Yeah.
Did you use the same, obviously, predation, the same Grayling? Because I don't know if they maybe learn how to avoid the ground trout better or illegal with the rookies or.
So there's for the predation trial, there's a chance if that survivors went back in. My tank was 120 gallon insulated tank, and there were about 5,000 fish in there. And I would take a random scoop of fish, put them in a bucket, and then randomly scoop out 20 fish to go into each raceway. So there's a chance, but it's unlikely. As far as competition trial, it was 20 fish in the control, 10 and 10. I chose my fish randomly, but tried to make sure that they were all in the same size range. And those fish stayed in the raceway for the total 2 months. Meanwhile, yes. I would love to have a fourth raceway. I really would. But I studied juvenile rainbow trout, E1s and E0s for my master's, and brown trout will have 2 rainbow trout. So I really kind of placed them potentially, and I could be wrong, because I haven't done the test, but I placed them in between the brook trout and brown trout effects. But usually if you have brook trout in a tributary and it's really good for trout community. It's like all of them for trout.
Work in the ground to
It can be, a lot of times they are, but brown trout are aggressive, they grow really fast, and they can push out other species. I mean, you can see that with fish trout too. That 10.87 brown trout grew to a greater size than my 8 ones that I started with in the 2 trials. Yeah.
Are you focusing on browns and rainbows because are they,
Brooks.
I'm sorry,
Brown and brook.
brown,
Brook trout in.
brooks, I'm sorry.
Yeah.
Because they weren't here when the grayling was here before, are there any other species that have been introduced that would be in
Rainbows.
competition?
So rainbows, Chinook, coho, those juveniles would all be competition. The main concern that I have are brown trout. I don't have as much of a concern for brook trout. Your Chinook and coho out-migrate much faster than do the other fish. Rainbows, I'm really not quite as concerned about either, but you could also have competition through suckers, darters, sculpin, dace. But when you have a high density of dace, you normally have a lower density of some of the colder fish. So you might not have as many brook trout when you find a high quantity of dace, just based on how they parse themselves out in stream conditions. So there's potential for other concerns, but those are the two primary.
What time of year do grayling spawn?
So they spawn in the spring as soon as ice out occurs in Alaska. So typically it's going to be earlier in Michigan. So as soon as the ice is off of our streams, they would be ready to spawn. And then they do have that really quick layover period. So one thing I'm wondering is how early are they going to spawn? And a lot of it's going to be based on when we're putting those eggs into the remote site incubators. So we'll have our broodstock held in broodstock ponds in the Upper Peninsula. When those fish are ready to spawn, that's when we'll be ready. Now, once they're creating a more natural self-thriving habitat or system, it could vary based on the stream, but it would typically be in that spring time.
How about in comparison to the other potential competitors like brook trout?
Brook and brown are fall spawners, but they stay within the substrate a lot longer, and they have a much longer time.
So is hatch out going to be at a similar time then?
No.
Possibly, could be a little bit later. Brook and brown might come up earlier, so they're usually up. Correct me if I'm wrong. Like Marchish. I think it's typically when they're out of the substrate. Yeah. Depending on the stream. Yeah. Okay.
I have to get confused sometimes about the history of something made. So we had a slide in the beginning that showed that the green, Arctic green, and the UP that we thought were kind of however,
Yeah. So, to begin with, it would have been from the recession of the last glacier. And that's when, like, the Montana grayling got to their habitat. And Canada, they have a grayling population too. So, the grayling focused here, we're covering the east. And we also think that the outer river, so the way that we think the outer river was transported is there's letter communications that have been found. And it leads to Native Americans not being familiar with the grayling in the outer river, which they were very familiar. It's a very culturally important species here in the peninsula for the Native population. And so that would indicate that it's unlikely the otter was native, or else it would have been more well known. Plus it's one river. So it's kind of common.
Were they basically the sole predatory fish
In the lower.
water?
They were the predominant salmon, north of the Buffaloes. The Jordan though did have that coexisting population of brooks and grayling, which does boost that they can coexist. And studies in Montana also showed similar results with brooks and grayling.
What caused you to choose the Alaskan strain instead of like something from Colorado or Montana or northern Canada? What caused that decision?
Yeah, so we did the genetics on a genetic analysis on Montana Grayling, and by the time we established a root stock from the stock they gave us, we would be at a genetic bottleneck. They were only native to like the Big Hole region, Missouri River Basin in Montana. So everywhere else they would have been introduced. So that's really kind of like one cohort of fish. If we were getting eggs from Canada, international transport of fish, it's a little more dicey, more paperwork. We contacted Alaska, and it sounds so far-fetched to take fish from Alaska and bring them here. But their genetics are great. It's a wild strain fish, so they've never, the way Alaska runs Grayling hatchery is they will stock their inland lakes for put and take fishery. They do not raise any grayling in their hatchery to put into the rivers. So all riverine graylings are a wild strain, and they haven't been diluted genetically. So that really kind of pushed us to that as a real healthy population.
How much difference is there between the hatch of the brooks and browns and the river? And then would there be a size difference that would be significant in the presentation?
So I think there could definitely be a size difference. As far as when they're going to hatch out in our strains, it's hard to tell. It's going to depend on when our brood stock is ripe and ready for spawning. So it could turn out with the short time that it takes for those eggs to develop and hatch, it could turn out that they're hatching out when the brooks and browns are coming out of the substrate, which would be beneficial because then you're flooding the spring system with a bunch of small fish. So there would be higher likelihood of survival. It's really hard to say. Alaska, of course, they're behind us in ice out. So their ice out this year was very end of April, beginning of May. And so they were just able to get in for these fish on May 15th. They were up there ready to spawn. So it would be earlier here.
Well, I want to thank Nicole, and I'm sure she'll hang around for a couple minutes if you have other specific questions, but I want to hold you guys hostage for lunch, of course. So a couple things. Thank you for coming and hanging out. In your folder, you have a fancy green paper that some of you have already found.